It's pretty much invisible. It moves at nearly the speed of light, and you use it every single day. Today, we're going to follow the incredible journey of electricity from a massive power plant all the way to the outlet right there in your wall. Let's dive in. You do it dozens of times a day without even thinking about it. But behind that simple flick of a switch, there's a story of immense power, incredible distance, and just mind-boggling speed. So, what really happens in that instant? I mean, think about that. In the tiny fraction of a second it takes for light to turn on, the electricity itself has already traveled maybe hundreds of miles through this massive multi-stage system. It's an engineering marvel we totally take for granted every single day. So how does it all work? Well, we can break down the path into four main stages. It starts with generation, then moves through high-voltage transmission and local distribution, and finally, it arrives right in your home. Let's start at the very beginning, at the source. Okay, first up, we're riding the high-voltage highway. This is where all that power gets created at a plant and then prepped for a really long-distance road trip across the country. Now, here's something you might find surprising. It doesn't really matter if the power is coming from coal or wind or solar, it's all generated at what's actually a pretty low voltage, somewhere around 24,000 volts. Now, I know that sounds like a lot, but to travel across the country, it's way, way too weak. So why not just send it as is? Well, it all comes down to one thing: efficiency. See, sending low-voltage power over a long distance is kind of like trying to force a river through a tiny garden hose. Most of that energy would just burn off as wasted heat. But by cranking up the voltage, it's like switching to a giant fire hose. The power flows with way less resistance and almost no loss. And we are not talking about a small boost here. Right there at the power plant, these giant transformers crank the voltage up to absolutely incredible levels. We're talking as high as 765,000 volts. This is that supercharged electricity you hear humming across the country on those massive transmission towers. Okay, so the power has made it across the country. Now it's time to take the off-ramp. Welcome to part 2, from the highway to your street. This is where all that high-voltage energy gets tamed for local use. Because obviously you can't plug your phone into a 765,000-volt line, right? The power arriving from the grid is just dangerously high. It's totally unusable for our homes and businesses. It has to be brought under control. And that is the job of a local distribution substation. You can think of it as the off-ramp of our energy highway. Using another set of transformers, it takes that massive voltage and steps it down to a much more manageable level for your town's local grid. And the change is, well, it's dramatic. We're going from hundreds of thousands of volts all the way down to a medium voltage, usually under about 34,000 volts. It's a huge drop, but believe it or not, that's still way too powerful to send directly into your house. Which brings us to the final mile of the journey, part 3, the final connection. This is how the power gets from the utility pole on your street right into your home. So how does it make that final leap? Well, it happens inside one of these, a distribution transformer. You've seen them 1,000 times, those gray cans on utility poles, or maybe the green boxes on the ground in your neighborhood. Their only job is to perform one last step down, taking that medium voltage and converting it to the standard 240 volts that your home is wired for. From there, a service line connects directly to your house. The electricity first passes through your utility meter, that's what measures how much you use. Then it hits the main breaker panel, which is basically the safety hub of your home's entire electrical system. And that panel distributes the power safely through the walls to every single switch and outlet. All right, so let's put this all together and take a look at the entire journey, from start to finish. This is how your world gets powered in an instant. You can see the whole process right here. We start with generation at a few thousand volts, then we step it way up for transmission, step it back down at the substation for local delivery, and then one final step down brings it safely to your home. It's this constant transformation, all happening for efficiency and for safety. And here's the most wild part of all this. This entire journey, spanning hundreds of miles with all these different transformations, it all happens in a fraction of a second. It's just a symphony of engineering that powers our entire modern world. When you really think about it, the system we rely on is this incredible feat of engineering, and a lot of it was designed a century ago. It works wonders every single day. But that leaves us with a really fascinating question. As our world changes with things like smart grids and renewable energy and electric cars, what will this instant journey of electricity look like in the future?